Review Chapter 3, Section 3.2 and 3.4, Empirical Rule and Z-Score. Lesson objectives. Use the empirical rule to describe data that are bell-shaped. Determine and interpret Z-scores. Lesson objective number 1. The empirical rule. If a distribution is roughly bell-shaped, then approximately 68% of the data will lie within one standard deviation of the mean. So if we go one standard deviation below the mean and one standard deviation above the mean, we expect 68% of the data to be within that interval. Approximately 95% of the data lie within two standard deviations of the mean. So if we go two below the mean and two above the mean, this will contain a 95% of the data. Approximately 99.7% of the data will lie within three standard deviations of the mean. If we go three standard deviations below the mean and three standard deviations above the mean, this will contain almost all the data, 99.7% approximately. This also works if we're using sample data. We would replace x bar in lieu of mu, and we would use S in place of sigma. Let's look at a visual. The distribution is roughly bell-shaped. We expect majority of the data, approximately 68%, to be within one standard deviation below the mean and one standard deviation above the mean. Now if we go two standard deviations below the mean, 1, 2, and two standard deviations above the mean, this middle area here, we expect it to contain 95% of the data. And if we go three standard deviations from the mean, 1, 2, 3 below and 1, 2, 3 above, we expect this to contain almost all the data, approximately 99.7%. Now let's do an example. The Stanford-Binet IQ test is normally distributed with a mean of 100 and a standard deviation of 16. Use the empirical rule to make a statement about the distribution of the scores. Now since we know this is normally distributed, it's bell-shaped, its mean it will be 100 and the standard deviation 16. So if we were to draw a picture of this, the mean would go in the middle, 100, and if we go one standard deviation below the mean, or 100 minus 16, we would get 84. And if we go one standard deviation above the mean, which would be 116. So we expect this area here between the scores of 84 to 116, this will contain 68% of the scores. Okay, if we go two standard deviations, this would be minus 16 minus 16. And if we go two above, that's 32 plus 100, 132. This will contain 95. And if we go one more standard deviation below and one above, we expect 99.7% of the scores to be within 52 to 148. Now let's look at some problems. What percent of the population has an IQ score between 64 and 116? It's always a good idea to draw the picture. So it turns out 84 and 116 is one standard deviation below and one above. So we know this is, by empirical rule, 68%. So that's our answer. What percent of the population has an IQ score less than 84 and greater than 116? Okay, from the previous example, we know between 84 and 116, this is 68%. So we are wanting less than 84 and greater than 116. So if we look at this distribution, we have what's called a left tail here, we have the middle, and we have a right tail. These three add up to be 100%. So if we know this is 68, to find the shaded region, we would take 100% minus 68, and we get 32%. Let's look at another example. What percent of the population has an IQ score greater than 116? Okay, if we look at our picture, from the previous problem, we know that this left tail and this right tail add up to be 32%. Now since this distribution is symmetric about its mean, the left tail and the right tail, they have the same area. these two add up to be 32%. If I only want one tail, all I would have to do is divide it by 2. So 16% of the IQ scores are greater than 116. What percent of the population has an IQ score less than 116? Okay, if we draw the picture of this one, and using our previous example, we know that this tail was 16%. We want to find what's the probability of being less than this. The shaded region plus the unshaded region equals 100%. So since I know this is 16%, all I have to do is take 100% minus this 16%, and we see that the shaded region is 84%. What percent of the population has an IQ score between 68 and 132? So when we draw our picture here, we see that this is exactly 2 standard deviations below the mean and 2 above the mean. So empirical rule said this middle area here would be 95%. What percent of the population has an IQ score less than 68 and greater than 132? Using our previous example, we know this middle chunk here was 95, so the left tail plus the right tail would have to be 5%. Next example, what percent of the population has an IQ score between 52 and 148? Now we see that this is 3 standard deviations below the mean exactly and 3 above the mean. So empirical rule says this is 99.7% approximately. Lesson objective number 2, z-scores. The z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. It is obtained by subtracting the mean from the data value and then dividing this result by the standard deviation. Now this is what the formula looks like both for a population and a sample. So here we have z-score for a population. We take our x value, we subtract the mean and divide it by the standard deviation. If it's a sample, we take our x value, we subtract the sample mean, x bar, and divide it by the sample standard deviation, s. The z-score is unitless. It has a mean of 0 and a standard deviation of 1. Here's a visual. We have 3 different normal distributions. They all have different means and different standard deviations. What's nice about the z-score is the z-score will standardize each of these different bell-shaped curves into one curve where the mean would be 0 and the standard deviation is 1. Now for the population of all adults in the United States, the mean height of males 20 years or older is 69.1 inches and the standard deviation of 2.8 inches. The mean height for females 20 years or older is 63.7 inches with a standard deviation of 2.7. Let's use z-scores to compare. Shaquille O'Neal height is 7'1". Candace Parker's height is 6'4". Who is relatively taller? Now because the females have a different mean and a different standard deviation, we have to find the z-score of both these, and whoever has the largest z-score will be relatively taller. Shaquille O'Neal's height is 7'1". Now, first step is we got to change this and put this in inches. 7 foot 1 inch is 7 times 12 plus 1, which is 85. I subtract that from 69.1, the mean, and divide it by 2.8, the standard deviation. So our z-score for Shaquille O'Neal's height is 5.68. Okay, Candace has a height of 6'4", so we have to convert this into inches. 6 times 12 is 72, plus 4 is 76. That's our x. We subtract the mean for females, which is 63.7, and divide by our standard deviation for females, 2.7. We end up with a standard deviation of 4.56. Because Shaquille O'Neal's z-score is larger, he is relatively taller. Here's the readings and suggested problems. Thanks for watching.